Good afternoon, everybody. Thanks for coming out. It's been a good turnout so far. We welcome you to the final presentation for the capstone project that we did through 2021 and 2022 with the Fleet Readiness Center East. You're looking at the agenda, what we intend to go over today. We'll start by talking about the MES program, talk about how we run capstone projects here. We'll then talk about the Fleet Readiness Center East a bit, as they're the customer for this year's project. Then provide some project background, how we really fit this MES capstone design experience to a Fleet Readiness Center East project. We'll then brief the design kind of at a high level, then work back through the design process on how we achieve that design, and then end it with some cost evaluations and open it up for questions of the crowd. So here at the MES program, we do design-only projects. That means 2 semesters of design work. That's a bit different from other schools where they'll do 1 semester of full design work and then a semester of building. Just for awareness, we do 2 semesters of design work. We follow the Department of Defense or DoD design review process, and that's shown here in the chart, starting with a system requirements review. Ultimately, trying to draft your design requirements. This is a detailed list or criteria that your design has to adhere to be successful and complete in the end. Leaving the system requirements review, this is the mechanical design that most of us here are familiar with. This is potentially bringing your 3D models, your big picture ideas. What you're really trying to do at a concept design review is show the customer, in our case, Fleet Readiness Center East, that we, 1, understand the problem and we have ideas to handle the problem and solve. We move towards a preliminary design review where we're just advancing the concept design. In other words, any models, material selections, dimensions, or load calculations are beginning to be honed in on. And essentially at this point in the project, it's a good bit done. You're just working, waiting for the finishing touches, finishing up your final deliverables to brief that at a critical design review. And this is where you brief your complete product, your design in our case, and it's ready for production. And I just mentioned that this is the process that the DoD uses, and it's often used at the Fleet Readiness Center East to design engineering products or processes. So we'll talk about the Fleet Readiness Center East a bit. I'm sure most of you are all familiar with how it works, but they are the customer this year. And what they do is perform maintenance, repair, and overhaul defense platforms such as H-53s, the heavy lift helicopter, or V-22s, shown in the graphics here on the right. It's also worth noting that they do maintain other defense platforms such as the F-35 fighter. But for the intent of this project, we're working with V-22s and H-53s. So just to talk about MRO a bit, you see the graphic down here on the bottom left. From a big picture standpoint, the military or the fleet owns aircraft, and then they come to Fleet Readiness Center East to get maintained, repaired, or overhauled. And what does that mean? Well, this picture provides a little context to that. You can see a V-22 under a big work stand, potentially some windows, some engines, some things out of it. So these aircraft will come in, these parts will get changed, potentially repaired, and go back into the aircraft. At that point, it would be considered overhauled. That really doesn't give it quite the glory that it deserves because a lot of these components themselves are quite complicated. They would come off and go to a whole entire respective shop throughout the facilities to get repaired, things like that. And to perform that maintenance, repair, and overhaul, those MRO processes, there's something called support equipment. Taka mentioned it earlier. And what this is, by definition, is a piece of equipment that's required to maintain the weapon system, but not required to operate the weapon system. So it's a bit of like special tooling, if you will. You could think about a specific type of wrench that had to be designed to reach an awkward bolt. That would be an example of what support equipment is. And it's really meant to advance, make these MRO processes more efficient. And support equipment engineering is exactly the team that our project has funneled through. and these guys in support equipment engineering, what they do is support and design new support equipment to advance or make these MRO processes more efficient. So they briefed us back in August of 2021 with the need for a dummy landing gear system that was interchangeable in V-22s and H-53 helicopters. Well, what is a dummy landing gear? So the graphic on the right, you're looking at a nose landing gear for a V-22, and a dummy landing gear would just mimic that. It's not meant for flight, it's just meant to stand in place of the operational landing gear. Well, why would we need such a thing? So through some research, we kind of found that ready for issue landing gears have some constraints on them at FRC East, whether it be OEM, supply, logistics, etc. And what a ready for issue landing gear is just a standard operating landing gear. It would be ready to go back to the fleet. So throughout those MRO processes, several things happen. Like I mentioned, you might have components coming off. You might be towing it around the facilities. And the landing gear is required to perform specific types of maintenance, whether it be taking heavy things on and off the aircraft. It needs the landing gear just to be sitting there for safety purposes. And then obviously you would need a landing gear to tow an aircraft. So you can still continue your MRO processes if, say, a landing gear had to come off. But at a certain point, you're going to realize that you need a landing gear to continue your maintenance phase, whether it be putting heavy things on or off the aircraft or towing it around the base, say, for paint. So in that cycle, you would eventually confine your aircraft to jacks. It's at a point where nothing can really be done and it's just sitting there. This is more of a problem that we found on the 53 side of the house. However, some of the V-22 MRO personnel expressed that V-22s will sit sometimes without landing gears as well. So what does that cause when they're just sitting there with no landing gear? Well, that's a deficiency in the MRO process. The maintenance repair can't continue. What is that doing? It's increasing the turnaround time from the Fleet Readiness Center East back to the fleet, potentially impacting readiness overall. So I mentioned it's a bit weird. I mentioned that we're designing a dummy landing gear system for V-22s and H-53s. It was meant to be interchangeable between each aircraft. Full transparency, I think I mentioned this, it's not meant for flight. These photos are showing them in flight just to show the landing gears on a V-22 and H-53. So you can see that's a bit of a design challenge, right? To have a system to interface with each of these components, because a V-22 nose and a V-22 main are not the same connection point on the aircraft. It's the same thing with H-53s. It's not the same connection point on the nose and the mains. So that was really one of our largest design challenges, was trying to incorporate a system that could work in all places. I'm just going to talk about our design a bit. We were able to make a system that was able to do that. I'm just going to talk about this big picture, and then we'll walk through our design process, how we got here. But you're looking at the system exploded up top with 1 and 2. This is what we're calling a modular trunnion and an aircraft specific adapter. This will interface with every aircraft we're looking at by changing either one, the specific adapter, or the 1 and 2 altogether for a new trunnion component. Why is that necessary? Well, a V-22 main landing gear has a bit of an awkward geometry, so that everything above 3 on the left portion of the exploded view would change. And that's really a big selling point of this design, right? Not only could this encompass the current aircraft, but potential future aircraft if you wanted a dummy landing gear to interface with those as well. So below that modular trunnion aircraft specific adapter component, we have a structural post. And what this does is just provide structure to the unit and interface the trunnion to the axle. That axle is designed with some pretty heavy duty thrust bearings to provide axial load capabilities, right? When you have an aircraft sitting on a design, it's pretty heavy, it has to hold it up. And then the axle can also pivot about the post. Well, you might think, well, main landing gears don't pivot. They're pretty rigid. So it does have a locking pin over on the right portion that is that it can incorporate to keep the main landing gear configurations rigid. You might could reference the 3D model up front to kind of get a completed version, see what it looks like kind of at the end game. Now, I'm sure there's a bit of questions at this point. Now Mike's going to walk you through some of our detailed design processes.
Hi, everybody. I'm Mike Howe. Once again, thanks for coming. So we'll go through the design process. Got to be over here. The computer doesn't like it. So first things first, as Aaron mentioned, the first part of our design process is requirement definition. So throughout the beginning of the project, we spent a lot of time just meeting with stakeholders such as the customer, Taka and Andrew, some of the guys on the aircraft lines over at FRC East, some of the artisans, some of the engineers, some logistics folks, all kind of stuff just to figure out what's going on, what do we need to do to build this product. So we came up with 15 detailed requirements. I'm not going to bore you with those details, but the main, probably the most important three were that we wanted it to be able to hold the capacity of an H-53 Kilo, which is the new aircraft being acquired by the Marine Corps. So that gives us about 20,000 pounds per assembly when installed. We had to do static and dynamic analysis in order to prove that we were able to meet that capability. So static analysis was basically just the aircraft sitting stationary, holding that weight up while the artisans are working on it and stuff is being removed and added or whatever is going on. Dynamic analysis would be when they're actually towing the aircraft around the facility, moving it around over different terrain, such as little tracks and stuff, doorway openings, all those things that the aircraft is going to interact with as it moves around the facility to go get painted or stripped or whatever else it needs. And then ultimately, probably the most important is it had to support towing. So it had to be able to interface with all the other support equipment that allows towing, such as tow bars and the tug tow tractor that you see here on the bottom. So the next step after we define those requirements is we broke off in some separate teams and we came up with some concepts as mentioned. So we had a few different individual concepts that were brought to the team. And one of those is shown here is basically, we called it the boat trailer design. It was basically a trailer that you would wheel up under the aircraft, remove the landing gear, and then first you would jack up the trailer as you see in the extended version, and then you would remove the aircraft, or remove the landing gear, sorry. And then you could just tow it around like that, pretty much just like a normal boat. Then we had the jack system, which is basically a jack that incorporates some wheels and interfaces for towing. So they could jack the aircraft, remove the landing gear, and then just keep it in the same jack point and tow it around that way. And then we had quite a few of the dummy landing gear design, as we termed it, which is basically a rigid form of the current landing gear. The current landing gear on an aircraft will incorporate nitrogen and hydraulic fluid to provide shock absorption and damping as they're obviously landing an aircraft on it. So these designs basically just forego that aspect of it just to provide the support that's needed for the stationary work and the towing. So basically, after we had these three designs, this was the method that was chosen to move forward with. So we basically brainstormed and got together and basically merged all the best aspects of these designs into our final design. So as Aaron mentioned, we have the structural post, the axle and all of its components at the bottom, the wheel and tire assemblies, and the modular trunnion. And for aircraft to aircraft, the only thing that will change, like he mentioned, is those specific adapters or the modular trunnion. And as you see here, we have that V22 main style modular trunnion that he mentioned with the awkward geometry that obviously wouldn't fit the other style. All right, so now I'm going to pass it over to Noah to go over the detailed design portion.
Test. All right. Before we get started, we actually have some smaller parts printed out. Gonna have the guys hand those out so everyone can get their hands on and see what we ended up with. So after we had settled on that concept that Mike just showed you guys, we had to break down. We had to break the class up into separate teams to tackle the different aspects of the design. So the way we went about doing that is we broke into a modular trunnion team, which encompasses the modular trunnion, like Aaron talked about previously, where you have two different trunnions that can be used, and then there's two different aircraft specific adapters that can be used. So that team covered the trunnions and the adapters, and then the second team was the universal portion, which encompassed the structural post and the axle and all its subcomponents. Once we had broken down into our teams, we could move forward into the first stage of our preliminary design. After going through preliminary design, this is basically what we ended up with. These are the various configurations that Aaron talked about beforehand, where H-53 needs a nose and main landing gear. And the only thing that needs to change for that configuration is those adapters up there slide in and out, because the nose configuration needs a narrower base and the main needs it further out. So all you have to do is loosen the bolts and move the adapters out. For the V-22 nose landing gear configuration, all that needs to be changed is the H-53 adapters taken off and that one adapter placed on, and now it can work on a V-22 nose. But then the V-22 main landing gear configuration has like Aaron said, it's a different geometry from everything else. So it needed its own trunnion, which is beautifully shown on our large model. So to make sure our design, we knew our preliminary design would work, we had to do some preliminary analysis on this design, which took the form of computer stress simulations. We used SolidWorks for this preliminary stuff, so we could quickly look at our preliminary designs and see what worked, what didn't work, where did we need to move material and adjust. But then we also couldn't just take the computer's word for what it was telling us. We had to verify everything we were seeing with hand calculations. There's an example of some hand calculations up there. And then there's also some various piece part components that didn't need stress simulations done on them. We just needed to know what kind of loads they would experience, and then those are parts that we would be purchasing, like like bearings or a few other parts. Once all of this preliminary analysis was done, we were able, and the customer signed off on what we had presented, we were able to move forward to our more critical design, where we could look at the parts a lot more in depth. Going to critical design, a few of the components changed just a little bit. A few of them maybe reduced material to save weight, so the parts could be easier to handle during assembly and usage. There were some components that we looked at them more in depth in analysis, we realized we needed to beef them up a little bit. So a few things changed along the way from preliminary to critical. This is where we ended up. Those are actually the parts that are being handed out right now, our final ones and the ones shown up there. Going into critical design, we moved to ANSYS, which is analysis software that can look a lot more in depth, a lot more rigorous analysis of our parts. We can get a lot better look and feel for how our parts are acting. All the parts essentially perform the same from preliminary to critical, which gave us a good feeling knowing that going between the softwares and the different designs, we're moving in the right direction. Every individual designed component went through ANSYS, and we verified that every component passed the requirements that we had set earlier. And then once every individual component was able to pass, we were able to do a full system analysis where we assembled the full design, excluding a few of the purchase parts that I mentioned earlier because they didn't need the stress analysis. When we had the full system assembled, we even had the attaching hardware, all the bolts, nuts, washers. And then we did the same analysis at the standalone. We applied all the forces that we talked about from the requirements. And once we were able to verify that all the individual components could withstand those forces and wouldn't fail, the design was considered complete. We knew we had a working design and it was ready for manufacturing at that point. And at this point, so the design was done. So I'm not going to hand it off to Cole now to go over to some of the project costs and acknowledgements.
Good afternoon, everybody. Can you hear me? Okay, now we're working. My name is Cole Brame. I was the Universal Axle team lead for this project. And, I'm gonna give you a little bit of details on our cost evaluations here. So for our engineering costs, we tried to quantify all the work that we put into this project. It was, some weeks were very heavy and some weeks were a little bit more slack. And through the end, we kind of come up with like an average of what each person in the class put into this project. So with 17 engineers and the base cost, I believe at the DoD at FRC is $150 an hour. We averaged 13 hours a week per student, and for 32 weeks, that comes up to a total cost of $1,660,800. Our unit cost come up to be $102,000 for an entire kit for all 3 locations on the aircraft. So 3 landing gear, 1 nose and 2 mains, totals $102,000. Parts and materials was $41,000, and our manufacturing labor cost was $61,000. We'd like to thank everybody acknowledge everybody that had a part in this, and we worked really well with support equipment engineering and V22 and 53 production support. Whenever we needed a question answered, when the guys that worked over there on base seemed that we could just walk over there and find the right person, they were more than happy to help us throughout. And they were understanding that we hadn't been working there as long as they have, so they might know some more things than we did. They were very helpful. Artisans and engineers and managers over there, everybody was very helpful throughout the way. Materials lab, the innovation lab for helping print off these 3D models here. And machine shop, we had the welding shop. We talked a lot with them. We were planning on doing some welding on it, and then they basically said that with the sheer size of our design that it'd probably be best just to machine it all out of one big piece and then basically have sections we bolt together where we could. But yeah, other than that, open it up for questions for the whole class now. If anybody has anything they want to ask, feel free to speak up.
You mentioned 53 Echo and Kilo. Just for my own knowledge, are those interchangeable from one to the other?
So no, currently we don't have the information to design to the 53 Kilo as far as the connection points and all that. So essentially what we did was we interpolated the weight and we designed the universal axle to hold the load that the 53 would have is what we think that the load was going to be. And then basically the top portion would have to be redesigned, but the universal portion was already, you could make it, similar to the 53 Echo, but it would just have to be maybe beefed up, or if there's another connection point, it might have to be moved for that.
Maybe just some different adapters.
Yeah, different adapters and stuff. We did the load capability so it would hold the weight, but we didn't have information for the connections. But yeah. Awesome, thanks. Anybody else? Now somebody else is dying to ask a question.
A little bit of a tricky question, but I'm really curious because it's a tough one to figure out. You talked about dynamic analysis. So how did you quantify those? You told like running over bumps. What did you use?
That's a great question. We had a lot of difficulty in the classroom doing that.
It's really tricky.
Right.
We
So
make container carts to move intermodal containers around. It's always a tricky thing.
that's right. If folks could get a dissertation on a dynamic loading, that would go inside this aircraft, right?
Yeah.
I'll stand up. So we had to make some assumptions, right? And they'll talk to that, but yeah, we sat here and said, okay, you look at airframes as a whole, right? And you have a bump on one side, what does that do to the rest of the aircraft? We kind of made an assumption, and again, you'll speak to it, that said, okay, the force will be applied to the point of the landing gear, right? That the other calculations were done, right, by Sikorsky's of the world and Bell Boeing's. And so from there, the simplified model is what they'll discuss.
Yeah, so like Dr. Dave said, we really just looked at the dynamic capability of our device. A landing gear, by definition, is a spring mass damper. A standard landing gear now. There's the damper is the shock strut. The spring is also within the shock strut, but a tire and on an aircraft tire also works as a spring with very minimal damping. So we modeled this as a spring mass damper. I'm sure you've all probably seen those in your engineering courses. It's basically just a mass with a spring underneath and it's attached to a fixed point. So we looked up the maximum deflection of an aircraft tire, right? We don't have a shock strut, so really we're only looking at dynamics of a tire. Looked up the maximum deflection of a tire, said, if this thing hits a bump, we're probably not going to be over maximum deflection. We're not going to be failing a tire. So basically solve the differential equation and set it up that way. A funny thing here, so Cherry Point provided us some impulse loading data for H-53s. They told us that to account for impulse loads, you just 2 times the static load. And it actually, through doing the math, actually worked out exactly that way, with no damping. Now, if you consider the minimal tire damping, which is like approximately 7%, then you minimize that load slightly.
I think that's a huge takeaway because there's a lot of problems in engineering where there's this huge drawn out thing and there's this quick little, there's a reason for those, right?
That was about a 3-week discussion in here.
I'm sure.
Yeah, other questions? And I forgot to introduce Dr. Dave Lewandowski, who actually leads their capstone design project.
So did you guys look into maintainability in the long run, right? You designed this pretty piece of gear that's going to go to this previous conversation, see some dynamic loading. So are you inspecting for cracks and maintaining it over time?
Yes, sir, that's correct. We actually, for the axle, the lower axle and the trunnions, we have bushings installed and like wear sleeves where the bearings are, just in case there was a bearing failure along the way somewhere. Instead of having to remachine a whole axle, we could just replace the sleeve on the axle. It's like a sacrificial surface, and to keep the axle together and make it last, but have smaller pieces that's very cheap and easy to replace. That's basically what we did. And like the bearings, they could replace those or just grease those over time. And I think we have maintenance instructions, right?
Our instructions you show a lot of because the whole thing's going to be mostly designed to be installed as one big assembly. We have the modular parts that we have instructions for them themselves, but the main part was to try to design it to as simple as a system as possible. So when if anything does get replaced, it'll be smaller pieces. The adapters could be the inserts, the sleeves. Same thing with, like you're saying, the bearing surfaces and stuff like that. So we're trying to keep it to the point where you could replace piece by piece as you go along. And obviously long length or like lifetime of it. And really, I think we'd have to go into further analysis to see where it would be at, but considering the simplicity of it.
Yeah. And of course we can do like, fluorescent penetrant inspection or eddy current.
Yeah.
Have those maintenance programs so that process, so we know that there's going to be a safe landing or dummy landing gear going on the aircraft whenever they're needed. Any more questions?
Mine's actually for Mark. Is this a project that y'all would want put in place?
Well, that's the design that's what's, I think, a little unique about this program, right? Is most of us that went to a big campus, you do design. I think we talked about it as a two semester design here. You do design and then the second semester you build, but I'll put that in air quotes because it's a pretty simplified project and it's really designed for an academic environment. For years now, the support equipment team has put forward projects that are in the queue. This is one that's in the queue that needs to be done. And ultimately, if this design is proven out by the SE team, this becomes something at some point in the facility.
Fantastic.
So that's a little bit of a difference, and that's a unique experience for this.
Well, just to piggyback on that as well. So just thinking about, as they come to my question, right? When I think back when I was in school, we weren't thinking about India, right? We were just doing basic design, right? Maintainability for a spender, all this kind of stuff was not part of it. So these are things that, assuming a lot of them, because I know some of them work for me, they picked up this kind of stuff as they worked, right, within our FSTs, within MRO engineering. And so it just, as Mark was saying, builds on the uniqueness of this program where they're getting the theory, but they're also getting the application piece, right? And then getting pushed from the sport equipment folks that come over and do this, the PDRs and CDRs are really relevant. So it's great to see that full kind of package, right? Where it's not just a theory, but it's measured.
So have you built a full-size prototype and installed it on a 53 or a 22 and actually seen it in action yet?
We have not had the time to do that. We did have these models 3D printed half scale. That's half scale, just to give you a good picture of what it would look like. But we didn't have the time frame to, get it built completely. That'd probably be a pretty long process to get it machined like that and all assembled and stuff. But I'm sure the people at FRC could handle it,
Well, that was my next question. I presume that FRC has the capability of milling this. I mean, you guys have CRC or CNC machines and lasers, and you can do all this.
Yeah, the SE team's doing this stuff all the time, so this will either be built there or some of it will be farmed out, or they'll do whatever with this design. Probably a few more tweaks, I'm assuming, and Taka would be able to speak to it better than I can. But ultimately, previous year projects have worked their way through the final stages, and we'll do whatever's most cost effective, build, farm it out, get it back, assemble, whatever it needs to be.
Yeah, and part of their design process was actually working with those people, and they modified their design based upon machinability and aspects from a manufacturing
Right,
viewpoint.
we spoke with the machine shop and basically we said, here's our parts, do we have the capability to mill these out, all as one piece? And once we got that information, that's how we kind of moved on, but, going away, like you'd say, going away from the welding and everything and do it one billet pieces.
Yeah, they actually gave us the ones recommended, even certain kinds of metals that would be better than some of the options that we had picked. Gave us, so this was a lot of it, if you were saying the acknowledgement on that, they actually helped us lead us to the better direction and stuff like that, after we had made all our notes.
Fantastic project.
Yes.
Oh, yeah, we appreciate it. Sir?
So, from understanding, the modular piece comes on the universal piece. Are they actually physically attached? And what are the design requirements that I saw was the amount of time that it takes to be able to switch? How long does it actually take to be able to switch out one module for the other?
Just be loose.
So I'll speak to the first question and I'll let the other guys take the second one. So you said, is it actually connected? Is that what you said? So yeah, maybe some of the pictures. There's actually a, yeah, so you can see right here, we have a bolted flange here. And basically the inside is just to add some rigidity, the male and female piece going in each other. And it would just be a bolted connection up top here.
You actually get bolted right in the two halves of the flange.
And we did a lot of calculation on that to see what size bolts we needed and how that connection should work in order to ensure that the thing didn't just snap off when they tried to pull it,
And just like the time to change, don't really have like a quantifiable number, but it would just be taking the bolts out of the flange and sliding the new one on.
Yeah, that was a big reason we went with this like shape and this like form of design is so it was very similar to what the artisans were already used to using every day, because it's very similar in size and everything to the actual landing gear. It just doesn't have the capability to land on it with the compression and the shock strut. So essentially it's almost just like the one that's on there, like minus the compression that it has.
So they can follow the same instructions that are already written for each removal and replacement for each one of them, and it's using the same hardware as well. So the same attachment hardware is also being used with the way we designed it this way.
So that was a big thing is like I'm a prior 53 guy in the Marine Corps, and so I got to use that. One of the things is when these get installed, the instructions will usually tell you to take tires off, pull the hole, pull the actual strut down. But one of the simpler ways that we've seen, actually talking to artisans to actually even do it, so you put like a jack underneath the actual whole strut, keep it in place, pull your trunnion pins, then you pull it down with the tires on, you can roll it out. So because this design kind of follows it, we went more towards that way, which is already, that's a way they already installed.
How do you ensure that they're not used in flight?
So yeah, that was a thing that we had to make sure we did not forget. We essentially at the end of this, that in the instructions, it's marked to be painted all red. So like as such as the ones over there now, like all the dummy stuff that they have, all the support equipment, just to be sure that it was not going sent up in the air with a working helicopter, because we don't know, we like to think it would land with it, but we don't know if it would handle that.
Yes, sir. So 2 questions. Number one, you were saying that the main gear, you have a pin so that the
that we in a fixed position.
Yeah.
But if by chance, for whatever reason, you wanted to move the aircraft sideways, would you be able to reposition those and get a second tow bar or whatever you need to do to push them sideways?
Yeah, we actually talked to the artisans on the line that maintain the helicopters, and they said that would be a big like to have, you know,
Yes.
because right now the helicopters are sit like this in stations, and they have to back them out and then move down or back them all the way out like this. And they said if we could just turn it sideways and push it, you know, this way, it would help them a whole lot. They don't have to move everything around. We're not sure if there's the operational capability to be able to push a helicopter to the side like that with the loading that would be on it. But if that was okay, if like they proved that it was okay to do that, then certainly you could take the pins out and then reposition it so they could push it to the side. Yes, sir.
We think that need to obviously analyze it more like procedures, obviously how to move an aircraft that way, considering it's essentially pushing a tricycle sideways, you know.
Yeah. You don't want to.
You would have to figure out where is a good spot and take more analysis, but the capability would be.
Yeah. And then number two, you have different adapters for different aircraft. So this may sound like a dumb question, but I could just see it happen. How does, if I'm the guy doing the maintenance on it, how do I know which one fits what?
So the plan was for in the kit, it would be labeled for every section, and like, you know, every part would have a name, and you'd know exactly that, you know, if you're the guy doing that, most likely you would have a clue that that's where that would go. And to be quite honest, most of the pieces, they wouldn't just work, you know, if it wasn't in the right spot, it just wouldn't fit there. And that would be your big red flag. You're like, okay, I need a different part.
Within the instructions as well, each instruction for installation for each one of them, it says to ensure that it's in the correct configuration. And there's a picture with a figure shown with each configuration, so they know that, you know, with especially with like the bolt stops for being further out for main landing or further in for nose landing, that's in the instructions to ensure that the bolt stop is in the correct place. And also again with that figure, so they can visually see whether it is in the right configuration or not.
Sure.
Did you guys have a limit for an angle as far as where it could be parked on the side slope?
Limiter.
Because you know
You're talking about turn limiter?
You know how the floor of FRCs is perfectly level, right?
Yeah.
No side slopes, there's no curves, there's no banks, there's things, right? So, do you guys do any side loading?
Other than just like hitting a bump, like and reacting against like a show load. No, we didn't.
So it can only be towed on perfectly flat level.
That's, you know, if those analysis are required, you know, to go over on level ground, then yes.
Okay.
But yeah.
Luckily,
We-
we're in North Carolina, so it's relatively flat. Okay.
We did check the load cases that they provided to us for support equipment and the 53 manuals and stuff. And it showed like, you know, if the tail pylon is folded, then there's more weight on one side than the other. And we did think about that. So we designed to that.
Different loading scenarios, right?
Yeah.
That's one thing to think about. You're always going to be flat, right? So if your load's coming in angles, CG's in a different spot.
Yeah.
What that would do to some, especially your pin locations. Right?
That's right.
There's adapters and shear too.
Well, we worked with the ANSYS guys over there at FRC and had them come talk to us and give us a little bit of an idea of how to use it and make sure we were analyzing it in the right way. Do what?
Different guys.
So for the axle team, like we had some issues with making this thing be able to be like practical size and hold the weight because of the factor of safety we had to design to. So they, you know, we were having trouble with yielding and stress concentrations in the axles. And basically the ANSYS guys they told us that they had worked on this problem on a previous project, and they, with the factor of safety that they had to meet, it was like impossible to get something that was like practical size and, you know, something that's comparable to what they already had with as far as weight goes for the artisans to be installing it. So like something may have to have some support equipment just to like push the stuff around and for the artisans to use it easier in the depot.
Anything else? Yeah.
That pin, does it have any kind of retention feature, stop it from sliding out during operation?
or to keep it attached to the actual?
You mean this right here? Yeah, so we had it where it's like got like a cotter pin in it. And when it was in operation, we were gonna have like a little cable so it didn't fog or something come off while they're towing it down the flight line or whatever.
Great. Okay, anything else? Cool. Thank you, Cole. And I did want to introduce Dr. Dave. Come on up, Dr. Dave. So again, one of the things we're really blessed with is having the resources at FRC, and Dr. Dave is available. So he actually is really the technical knowledge that teaches our capstone design project. I help with administrative kind of things, but Dave is really the knowledge person.
Wow, that's quite an introduction. That's why I never hear Dr. Lewandowski though. Look at Dr. Dave. You can't say it. I forget to say it. That will go better. Yes.
Did it go on?
Give it a second.
Push up.
Try it again.
There it goes. Yeah.
There we go. Me and technology. You know, I'm still working with the VCR at the house, so yeah, I can program that one of these days. No, just wanted to take the opportunity and really thank a few people. Bill did a great job of that before, but the students, right? They made this class really exciting this year, in a good way, right? When they stepped into the classroom, it was more of individual folks, maybe some teaming before that, with a lot of knowledge. But then when the pressure came on, they came together as a team, right? And there are multiple teams, and again, not in a bad way. Those teams kind of took their charge and said, okay, we have the various subsystems, and did well and worked well amongst themselves to be able to do that. So congratulations on that. Great job. Okay. Again, a few more thank yous out there. Basically, I want to thank FRC East, right? I'm an employee over there. They've been very generous in allowing me to come over here and do this work. Mark got me involved a few years ago. Thanks, Mark. No, no, it's been great, and I've really enjoyed it. But again, this gives us an opportunity to really get back to engineering basics and see what the teams can do, right? And this has been a great experience for me. Other folks I'd like to thank from FRC East be Andrew and Taka, right? The voice of our customer. They're in the corner
Yeah,
there.
let's hear for them.
Much appreciated. And
Yes.
other folks here, Brittany Klein, right? I remember all last summer, do you have a project yet? Do you have a project yet? Really pushing capstone. And Patrick Townsend for finally providing that project to me. And with this capstone, it's kind of unique, right? A lot of times we'll have projects settled, in the April, May timeframe. This one took into the summer because we know we have a little bit more time to get the project here, and we want to get a really special project over to the students here. From what Mark was saying before, these are things we want to implement. It shouldn't be just well, here's a project, go away, give us something, that's great, goes on the shelf. No, I mean, the approach here was to really use this project, right? The analysis that was done is to use this project and to field this. So with that said, community at large, right? You thanked a lot of folks before, and the community at large, the college, all of the just folks that we get support from out there, right? The interest that's generated. So thank you, heartfelt thank you. And as far as NC State, right, hosting the program here, and like we said, the folks who keep us in line, Susan and Michelle, right? Not just the students, you get the faculty. Bill and myself have a lot of fun with that.